Next, we'll be going over the different calculation approaches at each data quality level. So as we went over in our last lesson, the least accurate and lowest quality calculation method of GHG emissions accounting is to use spend-based data and spend-based emission factors. You will use this method when you don't have any specific activity data available per unit, such as therms of natural gas used or kilowatt hours of electricity used. So in other words, the spend-based method should only be used if no other data is available other than the money spent on that given activity. Now let's take a look at the example on this slide. Here we are going to calculate a facility's electricity emissions using spend-based data and EPA as the emission factor source. So first, you'll need to determine the source of your emission factor. In this case, we are using the EPA. Then, you'll need to locate the relevant activity you are calculating your emissions for. If the source of the emission factor does not provide a total CO2e emission factor, then you will have to calculate it using the combination of the three components, carbon dioxide, methane, and nitrous oxide, and their relevant global warming potential that we discussed previously. An example of these calculations is shown in the bottom right corner in step 3. You will multiply each greenhouse gas by its relevant GWP, and then add up those values to get your total emission factor in CO2e. Once you have the final number, you will have to adjust it by inflation, because most of the spend-based emission factors can be several years old. For example, EPA's latest is from 2018, and DEFRA's latest is from 2011. The inflation adjustment is shown in step 4, where you will use a credible source to apply the percent change in inflation to your emission factor to align it with your reporting year. Also, similarly, in some cases, you may have to convert the spend-based emission factor to your local currency if you cannot find a direct match to use for currency. So here is the complete calculation of greenhouse gas emissions using spend-based data for electricity, in this case a dollar amount of 2.4 million USD, and using the emission factor that we calculated on the previous slide. We multiply the activity data by the emission factor and get the final emissions as a result. Next, we will take a look at the medium quality calculation approach. So here we have the medium quality or medium accuracy calculation approach, which is one of the more commonly used methodologies. This approach uses activity data available in a volumetric amount. In this example, we are using DEFRA emission factors to calculate the emissions for natural gas use. We will go into the calculation itself on the next slide, but as noted at the bottom of this slide here, always be sure to pay attention to your activity data units. Make sure you are finding and matching appropriately to the emission factor, and convert the units appropriately if needed as well. Here is the complete calculation of greenhouse gas emissions using activity data for natural gas, in this case using the actual volume consumed in cubic meters by this example company, and using the emission factor that we located from DEFRA on the previous slide. Again, you can see the calculation of multiplying the activity data by the emission factor to get our final GHG emissions in the right side of the slide. The final highest quality and highest accuracy calculation approach uses supplier-specific emission factors. So for example, if your utility provider were to provide an electricity-specific emission factor, like we have here, then you would use that along with your electricity consumption to calculate your greenhouse gas emissions for that site. It is still uncommon to have access to these very specific emission factors, but this might change in the near future as suppliers advance in their own sustainability journeys. Next, we'll be going over how to fill data gaps.